All right, welcome to another episode of What's in the Box. I'm Tolgar Alpagud, VP of Marketing here at Tatsoft, and with me today is our founder and CTO, Mark Taccolini. How are you, Mark?
I'm great.
And if you're new to our series, we do this every Thursday at 4 p.m. Central Standard Time with myself and Mark answering questions. We take a deeper dive into the FrameworX platform and try to highlight some specific features, capabilities, functions, and get your questions answered. So if you are tuned in, we do encourage you to drop any questions you've got in the chat. We are also broadcasting this not just on LinkedIn, but also to our YouTube channel. And for those of you that may be missing an episode and want to catch up, it's also documented on our website, YouTube, as well as our forum at forum.tatsoft.com. So without further ado, let's get started on this week's topic, Mark, which is really about the powerful scripting capabilities within the platform as it relates to C#, VB.NET, and Python. So without further ado, please take it away.
Well, great. I think what I'm going to do, I'm going to share my display.
All right.
I think it would be more interesting to do in that way today.
Sure.
So here you should have it.
All right, it's live.
Perfect. Okay, first of all, some people sometimes get don't like the idea to do coding or programming. So let's make one point very clear. As much as possible, we try to do everything, drag, drop, all the objects, just put the objects on the display. But in real life, most medium to large size projects or almost any projects, you need to do some level of customization that we need to have some code, some logic behind your application. Unless some projects are very, very simple, just dashboard showing some information, we have that also. But when I leverage the full capabilities of the framework, we do projects that are running logic. Can be simulation, can be process workflow, can be analytics, can be logic to help integration with other platforms. So in this, our standard demo, you see we are running lots of quite complex simulations here in the demo. So let's see what do we have to work with codes. And instead of pick up and open one of our demos, I will go to a project that I have here. That's the one I was using last week. That's pretty much an empty project, and starting showing everything that we can do with codes in the platform. First of all, we start with the very basic. When you go here to this icon, you can change the color. Okay, so you see so you can read the codes. That's the first step to do scripting. You need to be able to read. So here you can change not only the color, but you can change the size of the codes, and you can change also the size of those grid lines here. So those fonts that you see on the grids, as well the font size you see in the code windows, and the colors, everything you can customize here to make it that more readable. Now that you can read, let me explain how we are able to put your custom logic in the application. The first place I will start is, of course, under scripts. We have that concept we call a task. A task is something that are going to run like by a time basis, every 1 second, every 1 minute, or we are going to run in reaction to some other events. For instance, you can run a code every time the server computer change the primary. If you switch from the primary to the backup server, or you can run a code based in another tag from the application, or any kind of events. You can run a code if you lose communication with a device or a protocol. So whatever the event is, or the code, you are going to run your logic, okay?
Okay.
And one concept that we have that's very powerful, we call it script because we try to make simple. You don't have to do the full Visual Studio programming. You just put your logic right away. But it's important to explain that's a little more than script. What you have here is the full power of the .NET languages, the same power you have in Visual Studio. So if I'm writing here some codes, so if j greater than 0, I'm going to run this code here, else I'm going to run this other codes here. You can very easily, from that code, access any variable from the application. Not only tags, but you can access, as explaining on the previous video, you can access any objects from the application. The alarm engine, the communication devices, you can access anything right away.
So, Mark,
go ahead.
Sorry to interrupt, but just, I always try to kind of simplify for folks like myself, but can you tell just, when, in terms of what you can do, what the difference is between C# and VB.NET, in terms of what you can do?
Oh, yeah, I showed that right away. Here, I'm using the syntax of C#. So I'm accessing the variables from the application. All those names that I'm showing here are the .NET framework with thousands of methods and functions to do everything that you may want with very high performance. And here you can access through C# everything that you have in programming Microsoft Visual Studio. We don't hold back anything. If you want to go to VB.NET, VB.NET is pretty much the same. Oh, you see I have an error here. And the error is, in some points here, I use an undefined variable, probably typo here. So let's delete those lines and see if I'll be good now. Hold on.
This is how we know we're in a live environment.
So okay. But frankly, let's say I did in purpose to see how it's beyond scripting. Is the full .NET. The error that I was having is that I was using the variable j without having a value for that variable.
Okay.
That shows that behind the scenes, we are really compiling the codes. It's not only a scripting. In most of the packets out there, they will not pick up this error eventually because it's see, I declared this variable and they start comparing. Comparing what with what? I don't have any initial value here. Okay.
Yeah.
So let's correct putting initial value to that variable, and now we have no errors. Okay. So the first thing about the name script, and go back to your VB.NET in 1 second, is we are really do much more deep verification than some other platforms. For instance, now I have a warning that the variable K was created but never used. So we do very deep verification. But anyway, you can do really advanced codes here. And the difference for VB.NET as for questions is only the syntax. And you even allow to switch dynamically from C# to VB.NET. So now you see the same code, the same logic, but use the VB.NET syntax.
So quite literally it's translating in real time.
It is. In VB.NET, you have if, then, else. In C#, you have this other syntax. But nowadays, with .NET, what you can do with one language or another language are pretty much the same. And in fact, we do that online translation. So when you deploy your application, you can have some parts in VB.NET, some parts in C#, and whoever needs to do maintenance of that application, if this code is not his language of preference, he can very easily switch to another one. Okay?
Yeah.
So here we are going to run, and to be clear, you have the full access of the .NET framework. And if you don't like neither VB.NET, neither C#, you also can create code in Python, okay? So when you create code in Python, it's pretty much the same process. You define when that code will be running based in this events or based in this time base. And when you go to the code editor, the only difference with Python that you use the Python edging tool and the Python engine. We didn't embed any specific Python editor inside our products. So there are 2 or 3 open sources that people like to use. You can use any one you want to use, okay?
It's a lot of flexibility.
And one question they ask me a lot. I'll talk more about Python integration a little later, so hold a little bit the questions. But one I will reply right away, because we received that a lot, is which version of .NET and Python are compatible. So for .NET, we need a .NET 4.6 or newer. And for Python, you can pick up any Python version, because when you do the configuration, you define here what is the runtime engine you are using to Python. So if you want to use version 3.6, 3.9, or some projects you are in 3.9, some projects use an older Python version, we manage that very nicely, because it's part of our configuration what engine we are using to run the Python codes, okay? But going back to the more high-level concepts, so those are tasks, okay? When you are running those tasks, it's very common that sometimes you have to call a function to repeat something all times. In this case, I'm calling this function to get the absolute value, and I'm calling that from the .NET itself. The Microsoft .NET framework has that method. But let's say you want to have your application, some other custom codes that you want to reuse in your application. That's what classes are. So on classes, you create here your class with whatever name you want to call, okay? And here you define what you want to do with that class. In this example, on that project, they are using lots of things here. They create a method to verify how much memory and how much CPU that compute is running is using right now, querying those computer performance tools, and make those performance tools available in tags to show on the display or to do something like that. So here we have all those methods that when you are doing your programming, the same way you can call like that a .NET library, you can call a class you define inside the framework. So if you go to script class, it will show the many libraries you created, and inside those libraries, you can pick up the methods you created inside those libraries, okay?
And so that really kind of relates to what we highlighted last week, correct? In terms of talking about the capabilities of the object model, things are an instance of a class, and then this is really just showing you how you can.
A class is our objects, and because of objects, I can use that from C#, from VB.NET, or from Python.
Wow.
So I cannot only select which language I want to use the application, but I can even mix those languages having interaction between them, okay? Yeah. And two more key concepts about tasks. One, sometimes when you do something very simple, you just want to add two variables when when a variable has a new value. It would be quite boring to open this code editor here and then type here only one line of code. So let me give one example. I just want to do something like my tag whatever equal tag.tag1 equal tag1 plus 2, something like that. To that kind of case, we have what the concept called expressions. Expressions is we are doing things that are very simple. For instance, in this example here, every time this timer happens, that's 1 second, I run that class that you get the computer performance. Or let me create here some new tags to give some examples. So I will create one variable called, because I'm not very smart today, I'll create one tag with name tag1.
Okay.
And something really very simple. I'll create another tag with name tag2. And obviously now one tag to call tag3. So let's say that I just want to have in my application that my, my tag 3 will be tag 1 plus tag 2.
Plus tag 3. Yeah.
I lost my audio. Can you hear me, Togar?
I can hear you just fine.
Yeah, I lost the feedback. Well, it seems I lost Togar feedback, but I'll keep running, assuming we are still live. So anyway, in this case, when you want to run that kind of simple expression, this code will run on change. It means when tag1 or tag2 has a new value, I run that event. So when you want to do things that are simple, like event scheduling or scheduler, we have the expressions that can, with very high performance, process thousands of events, tens of thousands, in a very high performance. And one question I also typically have in that point is how fast that can be. We allow here the configuration up to 1 millisecond. But I must warn that in general, most computers they can have plus or less 10 milliseconds in their clock precision. So you must be very careful when you do things high speed, because if you put something to run every 50 milliseconds, in some cases it can run 40, in some cases it can run 60. But that's because the design of the operating system itself, unless you have a real-time kernel. But you can run lots of code amazingly fast. If you put your 100 milliseconds there, you can create many and many processes. And the way we create the architecture of the products, we run very well with multi-core CPUs. So you have 10 cores, 20 cores, 40 cores. We use whatever power you give us. Okay.
Okay.
Good. So that's the concept of tasks. But let's explore the meaning of in our platform we call domain, server, and domain client. What's the meaning of that? Okay. One typical architecture that we have in the applications. Let's pick up some drawing here. Let's see. Where I have some nice icons here to put compressor, conveyor, furnace, in heat indicators, perhaps in miscellaneous. Yeah, I thought I had a PLC here, yeah. And I forgot to pick up also something like a computer. Okay. So anyway, a typical architecture is that you're going to have one server computer getting data from your devices. And typically nowadays, you're going to have many other stations that are only client sites that are essentially, you have this network. So you have this guy here, that's your main server computer.
Okay.
That I just put its height. Okay. So you have this guy that is your server that's running the communication with your devices, and the other stations on the top, they are pretty much operator stations, and those stations, we call those stations a client station. And everything in our software was designed to very easily deploy that kind of client-server architecture. So when you create some code to run, you can select it if that code is going to run on the server computer or on the client's computer. And you do that selection, use the concept of domain. And not going too much detail for time saving, but some examples on that. If I'm running here some codes that I want to do some work with the PLC data to do some filtering or some sort of analytics or to run some custom alarms, there is no need to run that code in all those computers. I can run the code in that computer and only do those client displays accessing that data. But let's say the code I want to run now is to do other type of action. I want to do data validation, or to be more precise, data entry validation. So I want my operator to type something here on my display, but before I commit that to the database or to the PLC, I want to run some logic on that. So I want to have code that's running on the client side. Because if I try to put all those operators, send the requests, and do all that verification on the server, it's possible. Many projects work on that way, but the programming, the synchronization, the performance is not as powerful when you allow the client computers to have more power.
If you not to hold you to any specific
So
number.
that's the concept of that 7 clients. So when you create those events, either here or here, they will run using as many CPU cores you have, and also you distribute that code to run in between the server computer and the client computers. And okay, let's talk a little bit about what we can do on displays now. Since I put the count of clients,
Okay.
let's explain other areas on the application where we can put some logic. In our demo that we're running, we have a few projects. We are doing simulation of those projects. Some of that data, we are doing the simulation on the server computer, but sometimes you want to put some logic running on the display itself. You want to create code specific to that page. So the way we allow that, when you are creating a new display for your application, you have the code behind, and the code behind specific to that page. So you can run what code you run when the display is opening, while the display is open, every 50 milliseconds or whatever. Or you can also put code in reaction to buttons and commands on the display. Again, you can switch the language. That's where you put the codes that's specific to that page. Okay. And the code you're going to do here is .NET, C# or VB.NET when you are deploying a .NET display. But we do have also the feature to create some displays application that are pure HTML5 clients. When you create displays that are using only HTML5 codes, so they are compatible to run in any kind of device, the code behind of that display would be JavaScript. So we still have the events, but the language you need to use for HTML5 is JavaScript. But even being JavaScript, you still can access all the object model I described on the previous video. All tags, all the codes, everything that's happening on your projects, all your objects, they're still accessible for the HTML5 displays as well. That's about the display. And I'm not going everything that's possible to do because it should be a long training. But keep in mind, those videos that I'm showing, it's just some highlights, okay? Because what we can do, it would be a full training, only 3 scripts or a few hours, for instance. When I'm putting a bar graph or put something on the displays, I can write .NET expressions right away from here. I don't need to go to that script. I can even call methods there. So keep in mind that in this video, I'm doing the highlights, not really all the details on the system. And we also have on those scripts very advanced debugging that I will only mention, but for time's sake, I'll not really run too much examples. But when you are creating that code, either on the displays or tasks, doesn't matter where you are creating your code, you can always put breakpoints. You can do step-by-step execution. You can monitor in real time what's happening. You can manage exceptions if you're familiar with the concept. So it's quite interesting. And I'm going to show that on the probably next week. that you can even do things that would create error on the systems, like put this variable to 0 and then trying to divide by 0. So if you try to do things like that, here you have an exception because you're trying to divide by 0. One thing that I'll cover in detail on the next section is that concept of intrinsically safe software. How we can recover from that and how you make the application that we don't have any kind of a break on the application running that. And one information about the questions, for whatever reason, I don't have any more the audio from Tolga. So from Tolga, I know you are hearing me, but I have only your chat window. Let's see if your audio is back. Try again.
Can you hear me now?
No. Oh, yes, you are back. I can hear you now.
Good. Yeah, no, I appreciate that. I'm not sure what happened, but
let's take that break that you're back to be able to get the air again. Yeah. And so far, Tolga, give me some feedback. Those concepts are clear in your opinion. Is there anything you'd like me to explore before I go to next topic?
No, I think this is clear. And if anybody has any questions, please do drop those in the chat. But I think we've already answered one from Pradeep earlier regarding Python. So I think we're good to go. The only thing that I wanted to ask you, Mark, was, and maybe you already covered it, but is how fast can we run the scripts?
Oh, yeah, I think I covered briefly that, frankly, is the limitations, the compute, how many CPUs you give us, we use that power. So we can process events in 10 milliseconds, 20 milliseconds, 50 milliseconds. In fact, we have some feedback that are some good competitors in the markets, but that when you need performance, performance on the display or performance in code in general, we don't have competitor because we can have displays with 1,000 objects doing updates in 50 milliseconds, 100 milliseconds, running applications using very powerful multi-core CPUs at several sides. And there is no other products, especially on the graphical sides, that match our performance because of the design. Okay.
So follow up to that then, when you were kind of drawing out the server and client with the monitors, yes, you had mentioned that the scripting, being located up at that level would help in performance.
Of course.
Is there a quantifiable, metric of how big of a performance change we're talking, or is it just kind of vary based on your systems?
It's a little complicated to publish a benchmark because the performance will vary based on the contents of the display or when trying to do.
Yeah.
But I'll give an example comparing, for instance, language like VB.NET that are doing the compiling with VB script that was interpreted language that some packages out there still use. The performance depends on your code was at minimum 10 times faster, up to 20 times, depends on the contents of the codes.
Wow, okay.
That's the difference of the behind the scenes compilation that we do, or when you have some language that is poor with interpretation. And one or two concepts of .NET, just for you to know that's aware there. We have that concept of Express projects, which allow you, even without license, to play a little bit with the software. But for when you are doing a real project, or even if you are a potential user and want to do the full speeds, we do recommend to contact us to receive what you call the enterprise license that unlock everything. For instance, you see now that I have this folder that I didn't have before to do very easy hot standby configuration. We also have an ability that wasn't before to add external libraries and external dictionaries, so you can have external .NET codes being used. So we give lots of things right away, even in the demo version. But just be aware that some more advanced features like integration with other packages or hot standby, you need the full version to be able to properly evaluate that. Okay.
Okay.
Good. What else we have? Let's talk a little bit about Python now, because I promised I'll go back to Python. So let's do that. Okay.
Okay.
And I believe I had here documents on that. Yes, I do. I think it's this one here. Yes. Yeah. I'll make sure as a follow-up that we have that on our forum. It's not there yet. But have these documents a little bit about how you use Python with our products, okay? And the first concept that I will explain very carefully is that there are 3 ways to use Python in our system. One way is to just run Python codes right away. You don't really has to think a lot on that one. Is what I was showing, that you go here on your scripts, your tasks, and you just put this Python code to run from time to time. That's the most simple use that you can do. Okay. Then you put the parameters. Let me show again, because it's good to start with the simple one. So here you select the code that's going to run. In this list, you can put the arguments of your codes. You select the outputs. There is no programming, no library, nothing. You just select the codes and pass which variables will be the parameters to your code. So here, I'm going to call some Python class. I'm going to give to that class the value of those 2 tags. So my Python code will use the variable of those variables in executing its logic. Okay.
Okay.
That's one thing you can do. Okay. Another thing you can do is that you can create .NET code calling Python codes or even Python objects. I'll not run now an example, but we can provide for we want. The .NET has that you can either from C# or VB.NET do one thing called PythonNet or IroPython. That was the former name. Where from the .NET code, you can also activate some Python codes and even interact with objects created on the Python system from your C# programming, okay? And finally, we have one thing that I call toolkit data access that allow Python codes to access Factory Studio objects, even from outside our environments. You want to develop only Python. You don't want even to use our programming tools, but you want to access real-time data from our application using Python. We have a data access toolkit that allows you to do that. Okay. I know all those scenarios can be confusing if you're not a programmer. It seems too many options. But believe me, when you find the real-time requirements, sometimes you need that, sometimes you not. So here the only point, and of course you have examples and detailed explanation in all those scenarios. In fact, that's one. That's an example how from the .NET code, you put some Python code to run. And the other scenarios, we do have examples here as well. So the points that's here is an example how I'm executing external Py application from my .NET codes. You see, it's quite simple. I'm calling Python execute Python file, and I give the file, and I get the error if there is one, and that's it. Okay.
Yeah.
So we do have really good integration between all those languages. Okay.
So just
go ahead.
As a backstory, where did the thought process come in terms of having C# and VB.NET and to be able to translate it? Where did you come up with that concept? Is it something in your own personal programming that you said it would just be more convenient, more powerful for you, or?
When we start that, the .NET framework is very, very, very powerful. When I did briefly here that I was creating some code, let me do that back. That I was here going through that system namespace from Microsoft. The .NET framework has literally thousands of libraries and lots of open source codes, and code with very, very high performance. And it's very powerful also as a language. We also decided to add Python now because for websites and some sort of analytics, Python is very suitable also. But the .NET framework is around for more than 10 years. It's amazing. Is still, in my opinion, the number one when you put the requirements on performance and you put the requirements on completeness. I want to do anything. Not only some analytics. I want to do integration with Microsoft tools. I want to do this and that. You have a huge amount of built-in code, examples from third parts, open sources, for very advanced features, especially also when you do integration with ERP or when you do enterprise applications. That's one thing also to keep in mind. Sometimes there are some platforms that they use a lot as example in some training classes. But when you go to the business world, the amount of companies that still have Microsoft.NET and Microsoft platform on their IT is huge. I'll not guess the number now, but it's still by far the Microsoft and the .NET platform is still really very, very strong on the enterprise IT. That's the reason we put so much emphasis on the .NET, okay? But to be clear, I don't want to start a war between programmers. We also acknowledge that are many applications nowadays that Python can be quite useful to some specific applications. That's why we decide to formally start to support that one as well.
That's great. There's a lot of flexibility there.
I gave the 10,000 feet overview, Toger. Do you have from the audience or from your own list some question that we did not cover yet?
Let me just check here with the chats. Bear with me one moment, but I don't see any new questions as of yet. But
so just to start wrap up, I put two concepts here. One, that's where we add external libraries. So if you have a .NET GLL that you want your application to use, we can just add that application. Doesn't matter for the server side or for display, you can add external libraries very easily. Okay, and this is not on the demo version. You need the full product for that. And another concept that's more or less related with script is the concept of tests and startups. Because all times that I was talking, I had a full server running. I was running here behind the scenes this application, okay? But when you are running an application, we still can open another project to test your code. So if I have this display now that I created, and I want to create some codes here, some very advanced programming I'm going to do here now. J equal 1, J equal 2, very advanced logic. and I'm going to put some breakpoints here, okay? If I want to test this application, use the debugger, all those things, and have automatic exception and error, lots of built-in validation, what I can do, I can put this application to run in test modes. So that's more or less connected with script. The concept we have startup is your production. So if I go here in startup, I see I'm running the project demo. The project demo is in fact running here. But I can put this other application to run in test modes. It will not conflict. I'm putting two complete isolated systems running out from the same server. Okay. And the trick is through that port number here. But anyway, I'm putting now this other application to run in parallel on the computer. And sometimes can be the same application. I keep the main project running. I do modifications in another instance of the project. I run my modifications in test modes. And when the application is ready to production, I put the application there. So that's how, and we have the concept here that you can attach and detach the .NET debugger to stop or not stop on the breakpoints. So we do have interesting features regarding how to debug that code, okay? And also, the final thing about logic, one thing when coding, you need to do inspection of variables. So here we have all the errors of the codes. You can add watch windows like you do in C#, and we have those very powerful debugging tools that can browse all elements from the application, your entire object lists, and we do have also one thing that you call trace window and mod information. It's like the Microsoft event viewer that picks up every process that is running and create a log on everything that's happened. We have those functions that shows only our process and pick up all messages, all error messages, all warning messages regarding your own codes. And you can customize the level of message. I'm not going that detail now, but keep in mind when doing really advanced programming that we have the built-in tools for code programming right away here in the Azure, but we do have those 3 external tools to give you high level of visibility for a more challenging application. And I think that gives a good overview of the scripting.
Yeah, no, that was definitely a lot in terms of, information in a way that I think is great, though, because I haven't seen it presented it like this, in terms of kind of getting the backstory, understanding the capabilities, the features, the flexibility. I think it was, I appreciate it.
In the traditional training video, we go to the details, explain the syntax, how you do programming, put examples. So I decided that was good to, instead of going that level of detail, have the vision of where I apply, what kind of languages, have the 10,000 feet without entering too much on the details of syntax or specific applications.
Yeah, no, absolutely. I appreciate that. And I think it was a great presentation. If anybody's got questions, please leave that in the chat here, or you can always post it on our forum at forum.tatsoft.com. Mark, go
And
ahead.
for next one, Tolga, I would say let's talk about that intrinsically safe concepts, because we did talk about programming this week. Let's explore what we have to make sure your code do not break your computer or your project. Even if you make mistakes, that's the key concept. If there is things wrong, the system will be able to recover and run safely. That's the concept we are going to explore on the next one.
All right, so for the next episode, we'll be covering intrinsically safe as it relates to the FrameworX platform.
Intrinsically safe software.
Yeah, if you've got anything that you want to say before we say goodbye
Thank you.
Oh, thank you as well.
You.
And thanks to everyone for tuning in, and we will see you next Thursday at 4 p.m. Central. Bye-bye.
Bye.